That's right, today we're talking about concentration. Hit the theme.
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu coming at ya. I'm your host Fu, and with me as always is Shu.
Shu know it.
So Shu, today we're going to learn about how to calculate concentration.
Really? Well, I better fire up my calculator then. So let's get started. Concentration, a lesson from the solutions unit. Molarity. Concentration relates to the amount of solute dissolved in a solvent. Previously, we've qualitatively used the terms dilute and concentrated to compare concentrations. To determine concentration quantitatively, we need a formula found on table T. Molarity equals moles of solute divided by liters of solution. So Fu, I found this cool animation to illustrate concentration. Want to play with it?
Yeah, let's check it out.
All right, I want you to shake the drink mix shaker.
Okay.
We're gonna add some drink mix to water.
Oh, look at that, that's cool.
We're making a solution. As you can see, it's turning red.
Okay.
And let's see, how could we make this solution more concentrated? Let's review those terms.
Well, more concentrated means I have more solute than I had compared to the solution, so I'm gonna add more drink mix.
All right, sounds good. How could I make this solution more dilute?
I would add water to dilute
right.
something, right? So this is a faucet up here, right?
You got it.
Oh, look at that. Oh, and it got lighter pink too.
Very good. You can see visually that it's a more dilute solution. Well, that's the qualitative part of things. Let's look more at the quantitative aspect of the solution. So we have a little concentration sensor off to the right.
Okay.
If we drag that onto the solution, it'll give us a molarity. Now, molarity is the moles of solute per liter of the entire solution, not just water.
Okay.
And we're getting a value right now of 2.733 moles per liter. That means we have 2.733 moles of the drink mix and a liter of the entire solution right now. Okay, so let's do what we did before. Let's make it more concentrated.
Okay.
What do you notice happened to the concentration, the
Oh,
molarity?
it's going up.
It's going up a lot. Again, we can visually see that it's getting darker, but we're seeing that our actual molarity in moles per liter is increasing. Let's make it more dilute.
Okay.
What do you see happen to the concentration as I add water?
Concentration went down.
Now, technically, we didn't change the amount of drink mix in there, but we increased the total volume by adding water, and mathematically, that makes the concentration go down.
Okay. Molarity is a unit of concentration expressed as moles per liter, or capital M, read as molar. Notice how the moles of solute are dissolved in a total volume of solution, not a volume of solvent. In other words, the liters contain both the solute and the solvent. So for example, a 2 molar solution of NaCl contains 2 moles of NaCl dissolved in 1 liter of solution.
Do you think that beaker is 1 liter?
Oh, I get it. 2 moles per liter. All right, ladies and gentlemen, we have an example problem here for you. Shu, are you ready?
I'm ready.
All right, how many moles of NaCl are present in 5,000 milliliters of a 6 molar solution of NaCl? All right, Shu, like all calculations, we're gonna do them FSA, so what's our formula?
Our formula would be molarity equals moles of solute over liters of solution.
All right, would you like to walk me through how you figured out it was that formula?
Well, they're asking for the moles. We're given a volume in milliliters and a concentration in molar, so that goes with the molarity formula.
Good, so you already told us that we're solving for moles and you circled it there, so let's circle that in our formula.
Right there.
All right, so now what's left in our formula?
The molarity and the volume in liters.
Okay, so let's get those filled in.
All right, so for our substitution, it says it's a 6 molar solution, so that would go over here.
Good.
And then the thing I circled, the moles, that's my X. I'm gonna label that X. and then divided by, I've got 5,000 milliliters.
Yep, gotta be careful here. It's giving you milliliters in the problem, but what are you supposed to substitute into the formula?
I want that in liters.
Okay, so what are we gonna do?
We're gonna have to convert.
Conversion factor.
All right, so let's kind of off to the side. We'll do 5,000 milliliters. I know I want my milliliters to cancel out. I want liters on top. And if I look at my reference table, I've got 1,000 or 10 to the third milliliters in 1 liter. The larger number getting the 1, that's liters. So when I divide by 1,000, I would just get 5 liters.
Okay, so let's substitute 5 liters in that.
5 liters.
All right, all that's left to do is the math. So how do we solve this? Looks like we have to cross multiply.
Okay, and you know what helps me if I put this side over 1 to remind me that I'm cross multiplying?
Okay.
And it just looks like it's 6 times 5 for my answer. That's just 30, right? So
yep.
X would equal 30.
Okay, what unit are we gonna have here?
Well, it'd be molarity times liters, but the question asked for moles, so I think it must work out that it's
Yeah,
moles.
so if you look at your formula, you circled moles, right? So that's a good way to check to see what unit you're gonna end up with too. So one last thing, let's just check our sig figs of the numbers in the problem.
All right, so this one up here has 4. I don't want to be thrown off by the fact that I wrote 5 liters because I didn't really think about sig figs then. I want to go back to the original. Although 6 molar has only 1 sig fig anyway. So 30 moles, it's not 30 points, so that actually would already be 1 sig fig.
We're good. All right, we have yet another example. Shu, are you ready?
I'm still here.
All right, good. What is the molarity of a solution that contains 170 grams of NaCl in 2 liters of solution? So again, let's do FSA. What is our formula?
Our formula again is molarity equals moles over liters.
All right, good. What is our question asking for?
Well, it says what is the molarity? So molarity is what I'm trying to find.
Okay, good job circling that in both the question and the formula. So let's figure out the other 2 variables there for moles and liters.
Oh, geez. Okay, well, I see that I've got 2 liters of solution.
Good.
But they don't give me the moles. They give me 170 grams of NaCl.
Ah, yes, those dreaded conversion questions where you gotta convert something before you plug it in. So what are we gonna do here?
All right, well, if I'm gonna go from grams to moles, I'm gonna need the molar mass of NaCl.
Yes, we are.
All right, so show some work off to the side here. So I've got Na, I've got Cl, got 1 of each of them, right?
Yeah.
And then rounding to 2 decimal places, which is what we usually do. For Na, I get 22.99 grams per mole. And for Cl, I get 35.45 grams per mole. I mean, they're just times 1.
Looking good so far.
I just have to add them up. And when I add them up, I get 58.44 grams per mole.
Okay, so we're gonna use that as our conversion factor here. So we need grams then, right?
All right, so I've got the 170 grams. So 170 grams NaCl is given. That's what I always start with. And let's see, do I wanna multiply or divide by that molar mass?
Well, let's let our units speak for us. So
All
what's
right.
gonna cancel out here? What do we want to cancel
We want
out?
grams of NaCl on the bottom so that they cancel out. And I'm gonna want moles of NaCl on top.
Okay, so then where does the 58.44 go?
Oh, it goes with the grams,
Always.
58.44, and I've got 1 mole on top. All right, so I just have to divide here, right?
That's right.
When I divide, I do, let's see, I don't really want to round this too early, right?
No, so this isn't going to be your final answer. So a good rule of thumb is to keep either as many decimal places
Okay.
as you want or a couple more sig figs than you need. Sometimes it's good just to keep as many decimal places as your calculator gives.
All right, so I got 2.908966. That should be more than enough for my answer so far.
Yeah.
All right, so substitution, molarity equals, I've got my moles right here, 2.908966 moles. And for volume, that was the 2.0 liters. I just have to divide one by the other.
Okay.
Pretty easy. And for my answer, molarity is going to equal, let's just get the sig figs right now. Looks like I've got 2 sig figs for both of these numbers, right?
Okay, so let's round to 2 sig figs.
All right, I get 1.5. My unit is big M, right? Molar.
Yep. You can use big capital M, or if you prefer, you can put moles per liter, just like your formula had also.
Sounds good.
You try number 1. How many grams of NaCl are required to make 4.00 liters of a 3.00 molar solution of NaCl? Be sure to show all your work FSA, don't forget proper units, and sig figs.
When you make the solution, you always measure out your mass of solute first and add it to the flask next. Add enough distilled water, not the total volume yet, to ensure all solute is dissolved by stopping and shaking the flask. Finally, you're going to add more water until the desired final volume is reached.
So we're going to assume that the volumetric flask we have below is a 1 liter volumetric flask. That means the etched line represents 1 liter of total volume. So the volumetric flask on the left has the solid solute at the bottom. Now we've pre-measured this to make sure we have the right amount of moles. We turn it to grams, measured it, and we place it in our flask. The wash bottle has distilled water in it. We're going to add that, not all of it. It's important that we don't add 1 liter of water, else we're going to miss our mark. If we look at the second image is stoppered and the solute is dissolved. That's because since it's stoppered, we were able to shake it and agitate it and make sure that all that solute dissolved. Now, once our solute is dissolved, we can take a look at that third image, which represents adding enough water, not 1 liter, but enough water to bring the total volume of the solution to 1 liter. It's important to remember that you're not adding 1 liter of water, you're just adding enough water to bring it to 1 liter. Dilution. Sometimes the solution is already made, but you need to use a lower concentration. This happens often with acids which are sold in very concentrated forms. You can dilute with water to make a new solution. Use the following formula from table T. M1V1 equals M2V2. M1 is the initial molarity, V1 is the initial volume, M2 is the final molarity, and V2 is the final volume.
Most of the time we solve for V1, so we know how much of the original concentrated solution to remove. Once removed, the concentrated solution is diluted to the new desired volume.
So if you take a look at the images below, we're showing you how to dilute a solution. So in our first flask, we can see that we're removing a certain amount of that concentrated solution. Now that certain amount, that's our V1. You're almost always solving for V1 in the molarity by dilution formula. Once that specific amount is removed, it's placed into a second volumetric flask, and we're going to dilute that with water. So we're going to add enough distilled water to bring that new volume to the line on the volumetric flask.
Okay, we're going to do an example using the dilution formula. You ready, Fu?
I am.
All right, what volume of 12.0 molar HCl is needed to prepare 250 milliliters of 2.0 molar solution? All right, Fu, we're going to do this FSA. What do you think our formula will be for this problem?
Well, it looks like it's going to be a dilution formula, so M1V1 equals M2V2.
Now, rereading the question, what variable are we going to solve for?
Well, it's saying what volume, and it's giving me stuff I'm preparing, so that's the end stuff. So it looks like I'm solving for V1, which is what we said we would typically be solving for.
Good, circle that variable. All right, so let's look at our other initial conditions.
Okay.
What would M1 be in this problem?
All right, it looks like I'm starting with 12 molar, so that's M1.
Good, that's the molarity of solution that we start with at the beginning.
Okay.
And as you can see from the problem, it says is needed to prepare. So what we're making at the end, our final conditions, would be what follows that in the question. So what would M2 be?
So M2 must be the 2.0 molar, so there's my M2.
Good, and how about V2?
It says 250 milliliters.
Good, that would be our V2. All right, looks like we're ready to substitute.
Okay, so that M1 was 12.0 molar. V1 is what I'm solving for. M2 is 2.0 molar, And I'm going to multiply it times V2. It says 250 milliliters. Do I have to change that?
Actually, you can leave it as long as we keep the same unit on both sides, we're good. We can do that in the traditional molarity formula. It's always moles over liters. But with dilution, if we keep it milliliters on both sides and we're consistent, we are good.
Okay.
All right, mathematically, what are we going to do next?
Well, I'm going to multiply these two together and divide by 12. My final answer should be in, looks like 2 sig figs. This is my least in my question. So V1 equals 42 milliliters.
Very good. You try number 2. If 50.0 milliliters of 1.0 molar NaCl aqueous is diluted to a final volume of 250 milliliters, what is the concentration of the new solution? Be sure to show your work FSA with proper units and sig figs.
Well, that's going to do it for today's episode on concentration.
It's been emotional.
Why did I say
So
unsure?
close.
So why did I say hopefully? Why am I saying, oh, that doesn't... Why did I say
I
net?
better stand up right now.
Flask up.
So good. That one stumble too, you could have Frankenstein.
Yeah. If you take a look at the images below, or no. So in the 3 flasks we have below, we have... Flasks? I want to Frankenstein this. Solute at the bottom. I should say to the left, shouldn't I?
Sure.
Right up to that etched line.
Most of the...
Zip it up!
I'm scat singing. Okay.
Today's episode is brought to you by...
Cy Hennington's connector cord. Cy says the perfect length power cord every time. 51-foot sections from 1 foot up to 50 feet.
Cy Hennington or any associate is not liable for incidental or consequential damages incurred as a result of using 51 or more connector cords. Results may vary.
But we never off, always on to the break of dawn. S-C-I-E-N-C-E in the hall they call S-Wing. You know we never wear a tie. Like my homies, boys to men, it's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.